Okay, so today we are starting Unit 7, and our first set of notes in Unit 7 is finding zeros of quadratic functions and solving quadratic equations by taking square roots. So we will learn several different methods of solving quadratics in Unit 7, so this unit is solving quadratics. And the first strategy we're using is the simplest, taking square roots. Okay, we will also learn how to solve quadratics by taking the GCF. Factoring by grouping, completing the square, and using the quadratic formula, and then when it would be best suited to use each of those different methods. Okay, so first of all, just as a refresher, the shape that the graph is showing is called a parabola, and we get a parabola when we graph a quadratic equation or quadratic function. Okay, so we want to talk about what zeros are. So zeros are where our graph crosses the x-axis. And when we have a parabola, we can have a few different scenarios. If we have a parabola that is a positive parabola and it's opening upward and its vertex is above the x-axis, then it wouldn't have any zeros. Okay? If we had, so no zeros because it doesn't cross the x-axis. If we had a parabola, or if we had a negative parabola with its vertex below the x-axis, same thing, no zeros, okay? No zeros. If we had a parabola with its vertex right on the x-axis, okay, whether that's a positive parabola or a negative parabola, we have 1, 0, meaning it would intersect at 1 point. Okay, so this parabola has 1, 0. This parabola has 1, 0. Okay, then if we have a parabola that intersects the x-axis in 2 places, which is pretty common. Okay, so we have 2 zeros. One on the left and the one on the right. And those zeros would be equidistant, so they're an equal distance. Okay, they would be equidistant from the vertex. Okay, so 2 zeros. All right, so again, it's possible for a parabola to have no zeros, to have 1 0, or to have 2 zeros. Okay, I'm not going to draw it because I don't want it to get too sloppy, but you could also have a negative parabola that, well, I'll go ahead and just sketch one. You can have a negative parabola that goes through the x-axis in 2 places as well. Okay. Okay, so again, the zeros are where our function crosses the x-axis. So when we look at graph number 1, we have 2 zeros. The first one is x equals 0. Okay. And these are always x values. Zeros are always x values. Okay, so because we're asking where does it cross the x-axis. So the first one is x equals 0. The second one is x equals 4. Okay, and this is a slight difference in terminology. If you are asked for the x-intercept, okay, you would list it as an ordered pair, and that's going to be 0, 0, and 4, 0. Okay, so the zeros, these are the x equals 0. Okay. When we are asked to list it and the request is for x-intercept, we give the ordered pair. Okay, let's look at graph 2. Our zeros are at -2 and +3. So x equals -2 and x equals +3. And we call them zeros because guess what? The y values will always be 0, meaning we didn't go up or down, we're directly on the x-axis. Okay, and that's the reason why they're called zeros. Okay, then when we want to list, when we're asked for the x-intercepts, we would write those as -2, 0, and 3, 0. Okay, so when we want to solve this algebraically, to solve and find zeros to quadratic equations using square roots, and this is solving it algebraically, to find the zeros or the x-intercepts, set the function equal to 0 and solve for x. So for example, if I have this function, f of x equals x squared minus 16, I'm going to set the function equal to 0. So we would say 0 equals x squared minus 16. Then we would start by solving, we want to isolate the x variable. Remember, we're using the order of operations in reverse. So we will add 16 each side. This will give us 16 equals x squared. Okay, and then we don't care what x squared equals. We do care what x equals. So we want to isolate the variable x. What is the inverse of squaring a number? Taking the square root of a number. In math, every operation has an inverse operation. Inverse is adding, is subtracting. The inverse of multiplying is dividing. The inverse of squaring is taking the square root. And we always follow that golden rule of algebra. Whatever we do to one side of the equal sign, we have to do to the other. So I don't want to know what x squared is, so I'm going to take the square root of it. Whatever I do to one side of the equal sign, I have to do to the other. We take the square root. Okay, so I'm going to say not what is, I'm going to say what are the square roots of 16. Okay, so, well, there are two of them. What number multiplied by itself will give me 16? 4. And what's the other number that also multiplied by itself will give me 16? -4. Okay, so when I take the square root of x squared, so if I have x, I square it, but then I take the square root, that's just x. Okay, so x can equal 4 because the square root of 16 is 4, or x can also equal -4 because -4 times -4 would also give me 16. So there, again, there are two possible answers for this. So the square root of 16 can equal 4, and the square root of 16 can also equal -4. But you know, us mathematicians, we like to conserve space and be concise. So instead of saying two separate answers, guess what we say? We say the square root of 16 is equal to, anybody know what the symbol we would use instead of writing 4 and -4? Yes, the plus or minus sign. So the square root of 16 is equal to plus or minus 4. So it's a smaller plus sign with a smaller minus sign underneath it, plus or minus 4. Excellent response. So x is equal to plus or minus 4, and that means 4 or -4. So the zeros will be x equals 4 and x equals -4. So this quadratic will cross through the x-axis in two places, 4 and -4. Okay, when we list that as x-intercepts, we would list those as, so the x values are 4 and -4. Well, and what are the y values? Well, they're always what? The y values are 0. The y values will always be 0. Because remember, your y tells you to go up or down. And if you're directly on the x-axis, you didn't go up or down. So the x-intercept we would list it as 4, 0 and -4, 0. Okay, let's go on to page 2. So let's do some practice problems together just to get a variety of different possible responses. Number 1, we have f of x is equal to 5x squared minus 45. So our first step will be to set the function equal to 0. So 0 equals 5x squared minus 45. And then we follow the order of operations in reverse. All right, so we are going to use the order of operations in reverse. So remember PEMDAS or GEMS. So we're doing our order of operations in reverse. So addition and subtraction is one step, multiplication and division is one step. So addition and subtraction. Is anything being added to or subtracted from our variable terms? Yes. There's a minus 45. So we will add 45. Whatever we do to one side of the equal sign, we have to do to the other. Add 45. So we get 45 equals 5x squared. We're done with the addition and subtraction. Is our variable term, so the x, is it being multiplied or divided by anything? Yes. It's being multiplied by 5, so we need to divide by 5. 5 divided by 5 is 1. So we have 1x squared, so x squared. Bring down the equal sign. And 45 divided by 5 is 9. Okay. And then we move on to our exponent. Okay. And exponent, so x squared, that's an exponent. So now we go to that, the exponent. X squared, how do I unsquare x squared? I take the square root. Okay, and the golden rule of algebra is whatever we do to one side, we have to do to the other. So if I take the square root of x squared, I need to take the square root of 9. Okay, so the square root of x squared, if I take x and then I square it, and then I take the square root, which is the inverse operation of squaring, I end up with x. And then what is the square root of 9? Well, there are two possible answers there, 3 and negative 3. Okay, because 3 times 3 will give us 9, and negative 3 times negative 3 will also give us 9. So x equals plus or minus 3. Okay? Okay, algebraically, you can check these by plugging them back into the equation. So 3 squared is 9. 9 times 5 is 45. 45 minus 45 is 0. Negative 3. Negative 3 squared is 9 times 5 is 45. Minus 45 is 0. All right. Example 2. This is a little bit different. So again, we're going to, we want to find the 0. Okay, so we're setting y equal to 0 instead of f of x. So 0 equals negative 15x squared minus 45. So again, we're following the order of operations in reverse. Addition and subtraction first, then moving on to multiplication and division, then moving on to exponent. So addition and subtraction, is anything being added to or subtracted from our variable term? Yes. There's a minus 45, so we add 45. So we get 45 is equal to negative 15x squared. Okay, then we divide each side by negative 15. Negative 15 divided by negative 15 is 1. So I have 1x squared, which I can just write as x squared. Then I have a positive 45 divided by a negative 15. A positive 45 divided by a negative 15 is negative 3. Okay, so first of all, we cannot, let's think about this. Does a number exist that when I take it and I square it, which means I multiply it by itself, that I get an answer that's negative? No. No. And why not? Because what's a positive times a positive? A positive. And what's a negative times a negative? A positive. So there is no number that I can take, whether that number is positive or negative or 0. Okay, there is no number that I can take and square it, which means to multiply it by itself, and end up with a negative answer. So anytime we are taking this, so if I were to solve this, if I were to go one more step further to solve this, I would take the square root of both sides. Okay. What is the square root of x squared? X. No problem. Okay. What is the square root of -3? No real solution. Okay. So there's no real solution. Okay. Because there is no real number that we can take and square it and get a negative answer. Okay, I cannot take the square root of a negative number. There's no real solution. Okay. When you are in Algebra 2, you will learn about imaginary numbers and how you can get solutions for this type of question, how to represent that algebraically. All right, so there's another type. So again, f of x or y, f of x equals or y equals. These are both getting set equal to 0. It doesn't matter. Okay, and then you're solving for your x term using the order of operations in reverse. And then if you are to take the square root of a negative number, there are no real solutions. Okay. All right, now let's look at when we have, instead of just an x squared, let's see how we would solve a problem that has a quantity squared. So instead of just x squared, here we have x minus 5 quantity squared. So let's solve this problem. So f of x equals, we're going to change that to 0 equals. We're going to bring down our squared quantity, x minus 5, quantity squared, minus 25. Okay, so now we have parentheses, which are way back here. Okay, at the beginning, we're using our order of operations in reverse, so let's go ahead and work on that. So addition and subtraction first. Is anything being added to or subtracted from our variable term? Yes, there is a minus 25. So we'll do the inverse operation, and we will add 25. 0 plus 25 is 25. Bring down the equal sign, bring down x minus 5 quantity squared. Okay, so then now this is the only thing on this side I have here is this quantity squared. This minus 5, I can't get to it yet because it's being squared and inside of parentheses. Okay, so my next step is I have to, there's no multiplication or division. There's not like a times 5 out here or anything. So I'm moving on to my exponent right here. I'm going to take the square root. Whatever I do to one side, I have to do to the other. So what is the square root of the quantity? X minus 5 squared is x minus 5. What are the square roots of 25? Well, there are two of them, 5 and negative 5, so plus or minus 5. So then there are two different answers here. X minus 5 can equal positive 5, and x minus 5 can equal negative 5. So we're going to branch that off into the two different possible solutions. And that's going to give us the two different zeros of our parabola. So when we graph our parabola, where is it going to cross through the x-axis? So what are those points? Okay. So our first possibility was the positive 5. So x minus 5 can equal positive 5, or x minus 5 can equal negative 5. And actually, I'm going to do the negative first, just to go from smaller to larger. Okay, so x minus 5 equals negative 5, and x minus 5 equals 5. Okay, so then I add 5 to each side to get x equals 0. I add 5 to each side to get x equals 10. And so these are our two different answers, our zeros. So x equals 0 and x equals 10. So when you graph this parabola, it will cross through the x-axis at 0, and it will also cross through the x-axis at 10. Okay, so that's a third type. All right, questions so far? right, moving on to number 4. All right, so here we have y equals negative quantity x plus 6 squared plus 5. So we're going to substitute the y with 0 so we can solve, equals negative quantity x plus 6 squared plus 5. Okay, we'll use our order of operations in reverse, so subtract 5 from each side. This gives us negative 5 equals negative quantity x plus 6 squared. Okay. I don't want to have the negatives here because I want to, so this is actually my multiplication and division. So this is all being multiplied by a negative 1. So I want to divide that out, divide by negative 1. Whatever I do to one side of the equal sign, I have to do to the other. So now I have a positive 5 because negative 5 divided by negative 1 is positive 5. Bring down the equal sign. Equals, and then this negative divided by negative is a positive. So now I have a positive x plus 6 quantity squared. Then I'm done with the multiplication and division. I divide it by negative 1. Now I move on to exponents, okay, which is going to, by default, isolate my parentheses, okay? So we'll go ahead. What is the opposite of squaring? Taking the square root. So I have to take the square root of this side, and I have to take the square root of this side. And I do it to the whole side, not just part of it, okay? So take the square root. So now I have the square root of 5. The square root of 5 is going to give us an irrational number. So if I were to, so this calculator is in math print mode. So if it were able to be simplified, it would put it in a root form that's simplified. Okay, so if I type in the square root, the square root of 5, it reads it as root 5 or square root of 5 because it cannot be simplified like square root of 4 is 2 or negative 2. So root 5, we're just going to leave that as root 5. Okay, if I put it in classic mode, you'll see it's an irrational number. It does not terminate or repeat. So root 5, and you can see it doesn't terminate or repeat. It just continues on. So this is an irrational number. I'm going to go ahead and put it in math print mode, back to math print mode, so that we get that precise answer, not rounded to a decimal place. Root 5. Okay. So if I typed in root 9, what am I going to get? Just a refresher, I'm using the square root button on the calculator. Root 9 would give us 3. We need to be aware that it's positive or negative 3, plus or minus 3. Okay, because we know that. We're smarter than the calculator. Okay, so back to number 4, we have root 5, and also, so we don't have to say square root unless you say a different root, like unless you say a third root, okay, cube root, fourth root, fifth root, sixth root. Unless you have another number, when you say root, it's assumed that it is a square root. And we don't even write the 2 there, okay, because it's just so frequently used that unless stated otherwise, it's assumed to be a square root. So unless you're told it's a cubed root or a fourth root or a fifth root, okay, we assume that it's a square root, and we don't need to write the 2. It's kind of like if I just write a number 5 or I write a number 6, it's understood that it's a positive 5 or a positive 6. Unless you tell me it's negative, it's understood to be, it's assumed to be positive. Okay, that's the default. So anyway, square root of 5, bring down the equal sign. Take the square root of x plus 6 squared, it's x plus 6. Okay, so now we're back to, we've isolated the parentheses, are gone now. Then we kind of circle back around and do our order of operations within the parentheses. Okay, and there's only one operation there, and it's a plus 6, so we do the inverse, which is subtract 6 from each side. 6 minus 6 is 0, so we end up with x equals. Okay, now when we have an irrational number and a rational number, we don't combine them. We leave it in this form. And we're always going to write the rational number first, so -6, and then add or subtract the irrational number last, and that's a positive. So we'll say plus √5, and that's the exact answer. You could get a decimal approximation, but we're going to just start to get used to leaving this in exact form, okay? So our answer, our exact answer is -6 plus √5. Okay, x is equal to -6 plus √5. If I wanted to get a decimal approximation, sorry, plus or minus, because I apologize, this is a plus or minus, because we're taking the square root, it could be positive or negative here. Okay, so -6 plus or minus √5, and got it there as well. Sorry about that. So just to reiterate, because I left it out here, we can have the positive or negative √5. Okay, so we could get our decimal approximation by doing this. So first, we would go to mode, and we would turn it off of math print mode because we don't want it to stay in that √5, and we would put on classic mode. Okay, so then we could say -6 plus square root of 5. Okay, that would be approximately -3.76. So if we were graphing it, we would say x is approximately equal to -3.76. And x is approximately equal to, and then we would do -6 minus √5. So -6 minus √5 will be approximately -8.24. -8.24. So if we were graphing it, we know how to graph these points, -3.76 and -8.4. So this would be the useful form. If we just want an exact answer, okay, we could leave it as -6 plus or minus √5. Okay, those are our two different possibilities. Okay, approximated form, exact answer. All right, let's move on to number 5. Y is equal to -x squared plus 100. So we set our y equal to 0. So we have 0 equals -x squared plus 100. We'll follow our order of operations in reverse. So we will subtract 100 from each side. That'll give us -100 equals -x squared. I don't want to know what -x squared equals. I want to get it to be positive, because I can't take the square root of a negative. So I'll divide by -1 on each side. This will give me x squared, which is what I'm looking for. And then -100 divided by -1 gives me positive 100. And then my last step is with my exponent. I'm working backwards, so this is my exponent now. X is being squared. I don't care what x squared equals. I care what x equals, so I take the square root. The square root of x squared is x. The square root of 100, well, there are two different answers, either positive 10 or negative 10. So x equals plus or minus 10. All right, moving on to number 6. We're going to pull it all together, multiple steps here. So we'll start off by setting it equal to 0 because we want to find the 0. So what is, when y is 0 or when f of x is 0, what is f? Okay, so we want to know where does it cross the x-intercept, and just like when we graph the line, if you want to know the x-intercept, you have to set y equal to 0, or if it's a function, you set f of x equal to 0. So 0 equals -2 times the quantity x plus 13 squared minus 10. Okay, so then we're following our order of operations in reverse. Okay, so here's our variable, x. We have parentheses, remember those will be last. So addition and subtraction, is anything being added to or subtracted from the variable term? Yes, there's a minus 10, so we need to add 10. Whenever I do to one side of the equal sign, I must do the other. That's the golden rule of algebra. So negative 10 plus 10 is 0, so that cancels out. On the left-hand side, 0 plus 10 is 10. Bring down the equals, negative 2 times the quantity x plus 13 squared. Excellent. Then I look back at my order of operations in reverse. I did the addition and subtraction. What's my next step? Multiplication and division. Okay, so is my x variable being multiplied or divided by anything? Yes, there's that negative 2. Okay, so I'm going to divide by negative 2. Okay, negative 2 divided by negative 2 is 1. Okay, so then I bring down this x plus 13 squared. And what's 10 divided by negative 2? Oh, also bring down the equal sign. What's 10 divided by negative 2? Negative 5. Okay, so now I'm not interested in what x plus 13 squared equals. I'm here in the next step. I need to simplify the exponents. Okay, so I need to take the square root. Whatever I do to one side, I have to do to the other. Can I take the square root of a negative? No, I cannot take the square root of a negative, so there's no real solution here. Okay, so I can take the square root of this side, okay, x plus 13 squared. Then if I take the square root of that, it's x plus 13. Okay, but then I end up again with this, x plus 13 equals the square root of negative 5. Okay, so there is no solution there. So no real solution because we cannot take the square root of a negative. Okay, next page. All right, so next we are going to look at examples that do not have a y or an f of x that is just an x squared, okay, in which case we will use square root to solve these problems, okay? So this is just solving a quadratic equation. So just a simple x squared, there's no y term or f of x term. All right, so for number 1 on this page, we want to isolate the x squared term. So we will add 4 to each side. This gives us x squared equals 9. Okay, then we don't care what x squared equals, we care what x equals, so we need to take the square root of x squared and the square root of 9. So we end up with, well, what is the square root of x squared? X. And what is the square root of 9? It's plus or minus 3. So our answer is x equals plus or minus 3. Okay, number 2, we have a three-step equation. So remember, we're doing our order of operations in reverse. Addition and subtraction is one step. Multiplication and division is one step. So is anything being added to or subtracted from our variable terms? Yes, there's a plus 2. So we subtract 2, which gives us 3x squared equals 12. Then we divide each side by 3. So we go into the multiplication and division. X squared is being multiplied by 3. So we divide by 3. 3 divided by 3 is 1. So we have 1x squared, or just x squared. Bring down the equals. And 12 divided by 3 is 4. Okay, so now we're at the exponent step. We take the square root of x squared. Whatever I do to one side of the equal sign, I have to do to the other. The square root of x squared is x. The square root of 4 is plus or minus 2. So x equals plus or minus 2. Okay, number 3. We have the quantity x minus 3 squared minus 2 equals 14. So again, remember, we're always following that order of operations in reverse. Okay, is anything being added to or so it's, our x term is locked in the parentheses, which is being squared. Okay, so we're going to do what we can. Anything being added to or subtracted from that variable term? Yes, there's a minus 2, so we add 2. This gives us x minus 3 squared equals 16. Okay, then we take the square root because we want to, there's nothing to multiply or divide here. There's like not a 2 out here or anything like that. So we take a square root of each side. The square root of the quantity x minus 3 squared is just x minus 3. And the square roots of 16 are 4 and negative 4, so plus or minus 4. So x minus 3 can be equal to 4, or x minus 3 can be equal to negative 4, two possible solutions. So we branch that off to x minus 3 equals negative 4, and x minus 3 equals positive 4. And I put them in number order, smallest to largest, because sometimes, not always, but sometimes when you're graphing compound inequalities, you're just graphing equations in one variable like this. It just helps you to visualize the number line a little bit better. Okay, so it doesn't matter though if you have the positive 4 and the negative 4. Your answers will be the same, and we're graphing them, so it doesn't matter. But let's go ahead and solve. Add 3 to each side to get x equals negative 1. Add 3 to each side to get x equals 7. So our solutions are x equals negative 1 and x equals 7. We box our answers. Okay, number 4. Okay, we want to add 8 to each side. This gives us 3x squared equals 15. Okay, our next step in the order of operations in reverse is to divide each side by 3. 3 divided by 3 is 1. So this leaves us with x squared equals 5. We take the square root of each side. X equals plus or minus root 5. Okay, and that's a square root of 5 is an irrational number, so we're going to leave that in root form. So leave that in exact form. If you needed to graph it, then you can round it to the nearest, couple decimal places so you can graph it. Okay, moving on to number 5. Again, order of operations in reverse. So we have a plus 4, so we will subtract 4. Whatever we do to one side, we need to do to the other. So this gives us 4 minus 4 is 0. So this gives us x minus 2 squared equals 10. We want to unsquare this quantity that's being squared, so we take the square root. And then whatever we do to one side, we have to do to the other. So this leaves us with x minus 2 equals root 10. Okay, and there are 2 possibilities, the positive or the negative. So we'll branch that out into both possibilities, either x minus 2 equals negative root 10, or x minus 2 equals positive root 10. Add 2 to each side. Okay, x equals 2 minus root 10. Add 2 to each side. Actually, we didn't have to branch this one off. We could have just left this, but that's okay. X equals 2 plus root 10, and then we can, I'm sorry about that, I just gave you an extra step of work there, but you can write this as x equals 2 plus or minus root 10. Okay, so we really could have left it, add 2 to each side, and just said x equals 2 plus or minus root 10. And I'm actually going to go ahead and erase that and do that, but you can see if you are get into that zone like I just did where you branch it off into the 2 possible solutions, that would be helpful for getting a decimal approximation anyway. But I'm just going to erase these. So hopefully we can build that habit of recognizing we can just add 2 to each side here. So sorry about that additional step, but that happens. By the way, I love these friction pens, so they're really great. They hardly leave any eraser dust at all. It's like little tiny pieces of, I think it's the actual paper. It's like the heat from the pen erases the ink, so they're pretty cool. They're friction pens. All right, so then we add 2 to each side. This gives us x equals 2 plus or minus root 10. Still want to make that problem look more complicated than it really is. It's pretty straightforward, actually. And then if you wanted to do the decimal approximation for graphing, you can. All right, and moving on to number 6. Okay, order of operations in reverse to isolate the x term. We'll subtract 16 from each side. This gives us, so 16 minus 16 is 0. This gives us 3x squared equals negative 12. Then we divide each side by 3. 3 divided by 3 is 1. So we have 1x squared, or just x squared equals negative 4. Okay, there's no number that I can square and get a negative 4, right? So I can't have, if it's a positive number and I square it, that's not going to give me a negative 4. If it's a negative number and I square it, that's not going to give me negative 4. If it's a 0 and I square it, that's not going to give me a negative 4. So I can't take the square root of a negative number. So this would say x is equal to the square root of negative 4. We can't take the square root of a negative number, so there's no real solution. Okay, so this is finding zeros of simple quadratics and also just solving quadratics using square roots.